Hello everyone, I am excited to share our research titled CampusVision, a deep learning based framework for enrollment forecasting of US higher education via IPEDS. And this project is a collaboration between Emporia State University and Rochester Institute of Technology. So in today's talk, I will highlight why accurate enrollment forecasting matters so much, walk you through our deep learning methodology and show the key results, and finally discuss what these findings mean and their limitations and where we are heading next. So problem statement. So why enrollment forecasting matters? So enrollment forecasting is at the heart of how universities plan, whether it is budgeting, staffing, and or long-term strategy. But in recent years, it's become increasingly uncertain because of shifting demographics, policy changes, and major disruptions like COVID-19. And traditional forecasting methods such as regression or ARIMA struggle in this situation because they assume simple linear patterns enrollment data. On the other hand, this highly non-linear and depends on how long term trends. So that's why we looked toward more advanced and data driven approaches. So data preprocessing. So for our work, we used the IPEDS fall enrollment dataset covering 2019 through 2023. So we first standardized the schema to align different years and removed incomplete records to keep the dataset reliable. Next, we designed three feature set, one using only total enrollment, one with gender based core demographics, and one expanded to include race and residency categories. Finally, we applied a sliding window approach, building both 3-year and 5-year sequences to prepare the data for forecasting. So methodology, our framework, which we call CampusVision, is built on an LSTM framework, so which is a type of deep learning model, especially good for time series forecasting. So the architecture includes 48 hidden units, dropout layers for regularizations, and a dense output layer for predictions. So we trained the model with the Adam optimizer and evaluated it using two metrics, the mean absolute error and root mean squared error. So to make the result fair, we compared everything against simple baseline, like just carrying forward the previous year's enrollment. The whole pipeline is Python based, open, and reproducible. So results, the best performance came from the model that used expanded demographic features combined with a 5-year input window, that configurations reached and mean absolute error of 0.25, and root mean squared error is 0.74, which is significantly better than the other baselines. So we also saw a clear pattern, richer features and longer sequences consistently produced more accurate forecasts. When we looked at training and validation loss curves, so they showed stable convergence with no sign of overfitting. Then in discussion, so what does it mean? First, adding demographic detail like gender, race, residency, so boosted accuracy compared to using totals alone. So second, longer historical sequences help the model capture deeper temporal patterns, which reduced errors. We also found that predictions were well calibrated, these most errors clustering near zero. So that said, larger institutions are a bit harder to predict because of their scale and volatility. These results confirm the reliability of CampusVision and show that it can directly support planning, diversity, equity, and inclusion efforts. In future work, like looking ahead, we plan to expand campus vision in a few ways. Like we want to integrate socio-economic and policy level data, since those factors heavily influence enrollment. We also test newer architectures like transformers to see if they can push performance even further. Also, we plan to apply explainable AI techniques so stakeholders can better understand how predictions are made. Finally, we'll benchmark across more institutions to confirm reproducibility. Then conclusions to wrap up, Campus Vision demonstrates that deep learning can meaningfully advance enrollment forecasting, and our best models using detailed demographic features and longer historical windows not only outperformed traditional baselines but also produced forecasts that institutions can actually act on. Because the framework is open, reproducible, and scalable, it can be adapted across different colleges and universities. And going forward, we'll enrich it with socioeconomic and policy data and experiment with transformers for even stronger results. Ultimately, our goal is to help institutions use data more effectively so they can plan better and adapt in an era of constant change. Here's the references, and thank you all. So if you have any questions, please feel free to send me an email. Thank you very much.